So our first of two talks will be by Joan of Netflix on Scala 3. What does it mean to me? Over to you, Joan.
I heard there's on Tubi, there's a section not on Netflix.
The most popular roads.
Okay.
That's how you know we're
Okay, cool. So yeah, today I'm going to speak about Scala 3 and what it means to us. So before I start, let me tell you a bit more about what my team does and what we use Scala for. So my name is Joan. I'm a data engineer in the streaming data science and engineering team. And so this is what most of my friends tell me. Netflix is just streaming movies. I don't know what else you're doing there. So let me just nail this question right now because I'm going to get this question all the time. So what these friends tell me is that basically he's telling us that we are a bunch of servers and we are streaming movies to his TV. So to put that in context, we are responsible for 15% of the internet traffic worldwide. And in US, at peak time, it goes all the way to 40%. So if we take back this schema, and it would probably look like this. So you may know we are fully hosted on AWS. And you're probably connecting to internet via your ISP, like, I don't know, I put Xfinity here. I'm not doing advertisement for them, but. And so we are communicating through the backbone. And so to our scale, if we were doing that, it would look like this. And so obviously the ISP wouldn't be too happy about that because both Netflix and the ISP would have to pay a lot in transit cost. And probably the ISP has to pay for all this infrastructure. So yeah, there's a clash here. So what we do instead, we have this Open Connect CDN. So it's a CDN that we call Open Connect. And basically, we just put those boxes directly into the network as close as possible to your homes so that we push only once the movie, and then you can stream from there. And so both the ISP and Netflix get back their transit cost. And even the latency is much lower for the users. So that's one thing we are doing. This is the holy grail of Netflix, at least for my team. So think of it as the CAP theorem. So it's like let's say you want to start fast your movie as fast as possible. You'll have to either cut on high quality or minimize or have more rebuffer. If you want to have high quality, you'll have to first do an initial buffer or to rebuffer during the video. And it works all four ways, basically. And so in my team, we believe that we can push that as much as possible, always further and further. And so to do that, we are doing a lot of A/B testing. So we are a data-driven company. So for those who don't know what is A/B testing, is just we take, for example, 1 million users, and we would take a new version and we would try that on 1 million user and see how it compares compared to the baseline, if there is a higher conversion rate, if people are more happy or not. And we are doing that not only with UI, but we are doing, we've been able to improve codecs. So this is a comparison with iTunes. Probably iTunes is not the right one to compare to because they'll come up next year with a laptop that is 3 times better than that. So yeah, they want you to load those movies as fast as possible. I mean, buy the laptop that is faster to load this content. So we do the reverse. And we also A/B test like anything, the trailer, even the images. So I don't know what you think about those two, but I prefer the second one. I think I would click more on this one. So there is another type of test that we are doing. I don't know if many of you know the Chaos Monkey. So this is a Netflix thing. So this graph, the top one, shows the number of stream starts per second. So it's the number of people starting a movie every second. I had to blur the numbers because they are not public. And the lower 3 graphs are the same as the top one, but per region, the 3 regions where we are deployed. And we can see that in EU West, the monkey just shut down the whole region for half an hour, randomly, like that. And so then the 2 other regions are taking over the traffic from from EU, and there's no impact on the global start stream per second. That's how we know that there's nothing. And so if tomorrow the continent, like Europe, goes down, or like US, you'll still be able to watch Netflix. Basically. That's what you need to think of. All right, so you probably didn't came here for like just listening to the Netflix stuff. So Scala tree. So just to clarify, there's a lot of talk about Scala tree, like most of them by Martin Ordesky or like the PhD students. I mean, Netflix is not using Scala tree, neither .e. We're just users, and I thought I'll reverse things a bit and talk about the issues that we have with Scala 2 that Scala 3 might resolve, basically. So it's kind of like not listing the features, but more listing the issues that we have right now that Scala 3 will, I hope, will resolve. So I'll do it by episodes. So I'll start with limited enumerations, an easy one. So that's how most of people, I mean, not most of people, but this is a way to create enumeration in Scala 2, I guess. And so, yeah, I guess you're probably familiar with it, but you just extend enumeration, and then you can have, there is a little bit of type wiring here. And then you can, probably I can point here, no? No, yeah. And then you have your 3 enums, let's say, values. And so the good thing I'm looking for here is I can get like values, all the possible values of this enum, and I can also, from a string, when I initialize, maybe from JSON, I want to get the enum from a string. That's probably the main feature of extending enumerations. Some other people do with a sealed thread and case objects this way, and that has the benefit of being able to extend it. Let's say you want to have a description, you can extend this way. But the issue is that you don't get the benefit of values and with name. That's the main drawback. And obviously there is some libraries like enumeratum that brings basically with some macros those values and with value. But you have to kind of introduce macros and bring in this library. So this is how Scala 3 aims to resolve this with a new keyword enum and cases. And you get the names has changed a little bit, but you have enum values and enum value named. So on. And so if you want to extend it as I did before with descriptions, you can do it. And so there's a bonus point where basically if you extend Java lang enum, your enum will be back compatible to a Java. So if your library is used, we have libraries that are used from Java at Netflix. Unfortunately, not everyone is on Scala. And we often have issues where we have to fall back to Java enums in whole Scala code just so that we can return that on the API. That's pretty good. All right, so either and co-products. We're using quite a bit of them. So let's say we have those 2 functions. One is like a simple one, audio. So you give it a movie ID, and it returns the audio for this movie as an array of bytes, and it might fail because not found exception. And so either you throw an exception, but this is not very functional. So what we do most of the time, we use either you get the exception or an array of bytes. A bit more complicated, the subtitles, for example, you give it an offset. It can fail in two different ways, either giving an illegal argument exception or a not found exception. And we can already see that in the type, we lost quite a bit of information. We just know the most common type exception. So I was thinking about union types, and this is perfect actually. So if I turn that into union type, that would be, I think, my #1 use case, where that function would return either an array of bytes or, and you can see here that we can return multiple exceptions. So we have full documentation on what this function does. So a little bonus thing. I don't know if you know the library Refined, but so since actually it's a feature in 2.13, but we have singleton types, and so we can do things like, you know, we can already do that in Scala 2, right? But you can refine and ensure that this function gets a positive int, basically. So you reduce the number of ways it can fail, basically. So Nulls, the $1 billion mistake. So I guess some people do that, and then it blows with a null pointer exception. And so what's the solution to that? Just don't use null. I think everyone keeps telling this, but still it happens. So, well, one way is use options, right? I guess most of you are using options. The problem is that I have colleagues that doesn't do, and I'm also using Java libraries that doesn't do. So I believe this is going to be enforced in Scala 3.1, not 3.0 directly. But basically, right now, the keyword null has a type null with an uppercase N, and that type is actually a subtype of all the types like nothing. And so this makes it possible to assign a null to a movie. And I believe they're gonna remove this subtyping thing, and so you won't be able to assign null to a movie, for example, here. It would just fail at compilation. And so if you want null, again, you need to use union type, and you say, okay, this can have a movie or null, and then you can't call duration on it. And so if you want to call duration on the movie, you need to pattern match on it. And you know, if it's a movie, then do the duration, otherwise do something else. I don't know what. But, yeah. And so, yeah, I found it interesting that you can actually combine those things. This can have a movie, null, so it's optional, and it can have also an exception. All right, extend Any Val. Who knows what extending Any Val does? What, 4 people? That's it? Okay, so okay, I think I don't need to explain why this is an issue. So let's say we have this record view function. Basically, it takes a movie ID and a user ID, and basically it records let's say in a database that this user saw this movie. And so you would call this way, right? You give it the two user ID, the two IDs, the movie ID and the user ID, and it records it, right? And so it would be nice if, you know, instead of using strings like here, it would be nice if we were using something a bit more documented. And to do so, we can actually use the type. But unfortunately, type is good for like documentation. But I don't know if you saw in this slide, there's a bug. The user ID and the movie ID is swapped around, and it compiles perfectly fine. It happens like, I mean, it happened to me a couple of times, copy and paste from somewhere else, and it was swapped. So the solution to that, some people do wrap the values into case classes. And so we can see that it doesn't compile at that point because you're using actual types for it. And the problem of that is you're creating classes for that. So you have an overhead at runtime. So to avoid the runtime overhead, you can extend Any Val, and it will basically inline everything. It's like if the case class didn't exist at runtime. And you get the benefit of compilation, compile time safety, and runtime benefit. So in Scala 3, there is a way to do that without a bit more explicit than extending Any Val. It's opaque types. So it's just like types, but it's not an alias. It's opaque. And so it's opaque only to the scope. It's basically not opaque to the scope where it's declared, and outside of the scope, it's opaque, right? So you opaque. What I mean by opaque is you don't know it's a string behind it. In this case, and so that's why I put an object here, a companion object, and I put an apply method to lift the string into a movie ID inside the scope, so that you can lift it outside of the scope into from a string to a movie ID or user ID. And so somewhere else you call the apply function here, and you get movie IDs, and you get the compile time safety here. And so we can go one step further. You know the refine thing I showed you? You can do it here. So I know a movie ID shouldn't be empty, so I can make it non-empty. And obviously here I need to handle a bit more, what if I get a string, an empty string? I need to, maybe return an exception here. And when I lift it, I need to handle the exception. That's why I put the 3 dots here. I don't have too much space on my slides, so it's a bit limited. Right. I'll go to the next one. So implicit classes. I have a friend who told me he's learning Scala, and he's speaking to me like when I saw implicit, that blew my mind. When I saw implicit classes, I was like, whoa, okay. I was like, yeah, I mean, this is probably going to go away, so don't learn that. So basically, I think most of the time we're using implicit classes to extend types that we don't have control on. I think so, most of the time. So here is an example that is actually in the standard library. And so it's extending the long here and adds the function seconds on it. And that's how you can call 5.second and pass it to a function that gets a duration, basically. So on a long, like 5, you do dot seconds, and it gives you a duration. So that's probably how you can implement it. And so in Scala 3, there's extension methods, which is, I don't know if there's any people doing Kotlin, but this is pretty much the same thing, where you can, you can extend anything here and add a function to this type duration, like the second duration. So type class hack. This is my preferred one, I think. So I think for people, I think I need to explain a bit more like type classes, because last time I did this talk, people didn't know what is type classes. So if you think about how would you do an encoder in Java, you would have a thread encodable, and let's say we have this class, this case class movie, and you want to encode it. So you would extend encodable on it, which will force you to implement encode. And then somewhere else, if you have the send function that gets any encodable, it can encode it and then send the data. Right. That's how you would probably do in object-oriented programming. And so the problem with that is you come up with this, then a colleague comes and say, oh, I need to compare those, extend compare. And then someone else, I don't know, he needs to clone it somehow. And then obviously we're all using Spark, so serializable, and then you just become mad. So there is a pattern here. It seems that we have the data structure and the data manipulation that is mixed up in the same place. So it would be cool to have a way to separate those two. Also, we can't extend anything that is out of our control. I used an int here, but all the dependencies that we have, if we're using a library, we can't make it serializable. How many times I came across this issue with Spot? So type classes are another way of doing, and you would have a thread encoder of T, and then you would have your type classes implemented here. So for a movie, you have an encoder for a movie, for an int, for whatever you want, and you can extend it. Right? You can have them wherever you want. You can implement them and then bring them in scope. And then your function will be, I can send any T, any data of type T, which can be anything, as long as I have an encoder in scope for that T. And then I can encode it and then send it. So one thing, also we can add, use implicits kind of like for dependency injection thing, like have the client here, the HTTP client, and send it, right? And so there is an issue here where there's a clash between two Scala features, the implicits and the apply methods. You can see here this function returns a sequence of string. And so it would be nice, I would like to get the first element of this string that it returns. And here, if you do that, it won't compile, and it will tell you, oh, I got an int, but I was expecting an encoder. So basically, it calls the second argument, the second group of arguments of the function instead of calling the apply function. So the fix to that is to explicitly write apply, which is a bummer, I think, for like two features are just like contradicting each other. So this is how I believe the keyword didn't change, the given. So this is how you would do it in Scala 3. And so you have this given keyword, which kind of replaces the implicit. And you would have a given for that type class, the implementation. And then here, just like the implicit, you have, I can send data given an encoder of T. And notice here that I skipped the name. You can skip the naming here. And notice also that I combined also the previous feature, the extension methods. If you put it directly inside the type class here, so this is like the type class is the thread. You can call it directly on the data. You can do toJSON directly. Just leave you to have a look. So, sorry, say again. So if you need the instance, if you need to catch it, there's actually, so I think in Scala, in Scala 2 you would do implicitly, right? Implicitly of encoder of the type that you want. You can do it in Scala 3, and it's called the, T-H-E. I don't pronounce it well. Yeah, I know that there is some benefit over the implicitly. I don't know too much. You can ask the question to Seth. It's here. Setting the... and so, yeah, coming back to my previous example, you can also add, a HTTP client as a yeah, there we go. I did the example you were talking about, the here. So I catch the HTTP client, and then I call send on it if there's a send function. And so here is another example with the name. If you don't want to use the function, you can name it if you want. It's optional. That's it. So untyped equality. So I did, this caught me not long ago, like 2 weeks ago. I did a refactoring. I'll show you. So basically, it was not that exact example, but again, the class movie. And you create one, the Black Mirror one. And see that we have a duration in int here, which is whatever, and you're like, so there would be like some other workmate who would come and say, hey, what is this duration? Is it millisecond, minutes, hours? I have no idea. So I would be like, okay, maybe we can do something here. So somewhere else in my code, I have this function is duration 5 seconds, and basically gets a movie and tells you if it's 5 seconds. That's it. So from here, you can understand that it was millisecond, right? But it's not very clear. So I come back to my class here, and I decide to change the type from int to a duration, so that it's clear. And now we have, again, like 5 seconds. I just did that, committed, CI pass, compiles, and you'll tell me, you didn't have tests. Yeah, I didn't. But yeah, and it pissed me off so much that it just passed here. Because it compares duration with int, and this is clearly never going to match. So this doesn't make sense. And so this is due to the fact that in Java, you equals takes an object, takes any, basically. So with that flag on the compiler, that wouldn't match, basically. So you'll have to refactor it to have the type that matches exactly. So thread parameters. When I saw this feature, I was wondering why would I ever pass like parameters to a thread? And I found a use case. So for those who are using cats and cats effect, maybe, you often have to do a service, and I ended up trying this, and it didn't compile because when you do this, this is basically an implicit here. You're creating an implicit, and that materializes in a parameter to the thread, and you can't have thread parameters basically. So yeah, that's kind of a bummer, and you have to because it compiles to this basically. And so in Scala 3, maybe that would look like this actually with a given, and even without the name, it would look like this, right? And it works. I tried it, and it's so good. I can't wait for this because there's hack stuff everywhere because of this. Yeah, comes back to this. So tuple deconstruction in functions. That's a short one. Basically, whenever you have a tuple in a list or an option, whatever, and you map over it, and you want to get the actual elements in there, you have to give a partial function in it, and you need to match. Actually, I don't know if it's in partial function, but it's just a match. You match to deconstruct the tuple, just like you would deconstruct a case class. And so in Scala 3, you don't need to match on it. It will deconstruct it for you. Yeah. And yeah, we don't have to change those brackets. I keep like every time like I need to go on the left, change the bracket into a curly bracket, go on the right. It's just annoying. It's like when you do 20 times this, it's like. Last one. So do people recognize themselves here? So cross compilation mess. So you might wonder what, like, this is cool, all those features, but when are we going to get them? It's already messy when 2.13 was out. How many people are on 2.13? You are. I can't believe this. So I guess it's going to be even like bigger, maybe, with Scala 3. So basically, the issue right now that we have is if you have your project on the right that is on 2.12, and you depend on a library that has been compiled in 2.12.2, you can depend on it. And then if you upgrade to 2.13, basically you break your binary compatibility. So you cannot upgrade until your library that you depend on as upgraded to. And so what your library is doing, because not everyone is upgrading at the same time, they would have to cross-compile basically everything into multiple versions. Usually it's 2 versions. And so you might think basically it's going to be the same thing for Scala 3, but so the plan is that in 2.14 we'll be able to compile to an abstraction called tasty. And so from tasty, basically it's a format. Tasty means typed abstract syntax tree, and why? We have no idea why. And so from that abstract syntax tree, we would be able to reconstruct the bytecode basically. And so we would have forward and backward compatibility. So you would be able to depend from Scala 3 to Scala to a library that is compiled with 2.14, sorry, and also the other way around. It works also. So if you're a library maintainer, you would be able to support 2.14. But again, Seth has more information on that. That's it. So I just encourage people to have a look at the feature on .e.epfl.ch. I played a lot with on Scasti, and it's actually really accessible. And I was surprised at some point. I tried some stuff and didn't work as advertised. I went on the Gitter, just said, "Hey guys, is it working?" And I saw Martin Odeski coming. "Oh, sorry, I'm going to fix that." It's like, wow, yeah. Obviously, we are hiring just like everyone. Thanks.
Great. Thanks so much, John. Really appreciate it. Thank you.